everyone, and welcome. Thank you for attending this session, Accelerate Building AI Applications with Cloud Run. My name is Sara Ford. I am a Developer Relations Engineer at Google on the Cloud Run team. In this talk, you will learn about Cloud Run, which is Google Cloud's easiest and most convenient place to run backend code written in any language. And you'll also see 3 demos on how to incorporate AI workloads on Cloud Run. First, you'll see a demo on how to incorporate Gemini into a Cloud Run app. Then, you'll see how to use function calling with Gemini. And lastly, you'll see how you can use the specialized Vertex AI APIs using Cloud Run jobs. So you can think of this as a mini buffet, a small mini buffet of demos, something for everyone. Now, you might be familiar with the term serverless. Let's talk about how that concept of serverless helps developers. By being in the cloud, you don't manage physical servers anymore, but now you find yourself managing scaling. And you don't want to manage scaling. Instead, you want to focus on what's core to your business, which is your application development. And with serverless, you get performance monitoring out of the box. Here's another way to look at serverless. Here's traffic from a Google Cloud customer website used with permission. Customer traffic is bursty and unpredictable. If you are managing scaling, you have to make sure that you have enough capacity to handle the current customer load. For example, you need to over-provision the blue areas with servers that can handle that traffic. But what if your site is mentioned by a famous influencer, as shown by this unexpected spike? How are you going to scale if you are manually managing the infrastructure? One possible solution is to over-provision. But that's not fun either, because now you're paying for all that unutilized resources indicated in the dark blue. Scaling can be challenging if you want it to be cost efficient, because you have to make sure that the capacity closely tracks demand. By letting serverless or Cloud Run handle auto-scaling, you pay for what you use. Or to use a calculus analogy, because you can't have a Google talk without a math joke, think of it as paying for the area under the curve. Cloud Run is Google Cloud's serverless engine. With Cloud Run, you can run any container on demand without any infrastructure management, no VMs or clusters to manage. And there are 2 types of Cloud Run resources: services and jobs. A Cloud Run service follows request-driven scaling, and instances are scaled behind a Google-managed load balancer, providing out-of-the-box URLs and TLS termination. A Cloud Run service has multiple trigger sources, like HTTP2, gRPC, events, and WebSockets. And you get traffic splitting and gradual rollouts. The other type of resource is a job. Cloud Run Jobs runs a container to completion. They are not triggered by HTTP requests. Cloud Run Jobs can be executed manually or automatically on a schedule. And you pay only while the job is being executed. You will see both types of resources demoed today. Although you get auto-scaling out of the box with Cloud Run, there's additional fine-tuning you can do for certain workloads or anticipated high-traffic events. By default, Cloud Run spins up an instance to handle serving requests. Now, when there are no requests, Cloud Run will keep that instance idle up to 15 minutes for free before scaling it back down to 0. And Cloud Run will automatically spin up more instances as needed based on incoming traffic and current CPU utilization. Now, if you want to keep a given number of instances ready to go or warm to improve latency, you can use the minimum instances feature. Now, you pay for minimum instances, but you are billed at a reduced rate. To be clear on terminology, we define concurrency as the number of requests a single instance can handle at one time. By default, Cloud Run sets this value to 80 requests per instance. So for example, if you have 5 instances in the active state, this means that every instance can handle up to 80 requests each. Let's talk billing. Cloud Run Service provides multiple pricing options. The default plan is pay per request. This means that you will only charge when the instance is handling requests. It's kind of like leasing a car, but you're only charged while driving the car. Whenever an instance is put into an idle state, the CPU is reduced to conserve resources. You can enable CPU always allocated to keep the CPU ready to go. Keeping the CPU always on can also reduce costs if your service is under constant load because you can take advantage of the reduced prices. And if we determine that it would be cheaper for you to have CPU always allocated, you will see a recommendation in the Cloud Console for Cloud Run. Okay, now it is time for that mini buffet of demos. For these demos, do not take notes. I have written a corresponding code lab for each one of these demos step by step by step. And you will see these QR codes at the end of this talk. And for each of these demos, I'm going to go over a few slides illustrating what you will see in the demo. And again, I will show these at the end of the talk. Okay. So for demo 1, in this first demo, you'll see how you can deploy a Gemini-powered chat app to Cloud Run. And you'll see how you can use Google Client libraries to handle authentication to the Google APIs for you. Let's go over how that works. Authentication is handled by a strategy called Application Default Credentials, or ADC. The Google Client libraries automatically use ADC to find credentials based on the environment the application is currently running in. Then ADC uses those credentials to authenticate to Google APIs. You'll see how ADC works in the demo when I use the Vertex AI client library to connect to the Gemini APIs. Your take-home message is when you use Google Client libraries, authentication to Google APIs happens automatically for you. And third, you're going to see in this first demo how Cloud Run uses build packs to automatically create a production-ready container based on your source code in case you do not have a Docker file. Now, if you have a Docker file, Cloud Run will use that Docker file instead. Let's go to the first demo. So here I have an Express app written in Node. And I'm going to start this locally. And so this is the chatbot app. And right now, okay, and what we're going to do is add Gemini. And we're going to ask Gemini, C#, programming language or musical note? Where are my musicians? I know, okay, there you are. I know there's a few out there. All right. And right now, I've hard-coded to say to be implemented. Let's add Gemini. So first, I want to walk you through the code. So again, it's an Express app written in Node, and I'm using WebSockets. And here you can see the WebSocket handler for a send message. And when it receives a message, the WebSocket receives a message from the user. I have it here, hard-coded to be implemented. Now, you might have noticed I'm using literal HTML. That is because, let's go to the index.html page, the front end, and then we'll go to the top. This is because I am using HTMX. HTMX allows you to dynamically change the DOM without needing a front-end JavaScript framework. And if we scroll down, this div to update, This is a div that will be updated with a message from the user and from Gemini. And this is the form where it has the HTMX attributes to wire up the WebSocket. All right, let's go back to the main app code. And let's go to the top and now add Gemini. Okay, so the first thing we need to do is add include a reference to the Vertex client library. And I am using VS Code user-defined snippets. So I'm using code snippets that I've previously written to insert it here. And just to show, in this .vs code folder, here you see all my code snippets that I'm inserting. Okay, so the first thing I did is get a reference to the library, and I'm going to save an instance of the Gemini model in global scope. This part here, app.listen, this code is run whenever Cloud Run is spinning up an instance. So that's only run that one time when the instance is spinning up. So here I can instantiate Gemini. So the first thing I need to do is instantiate the client library. We'll come back to project and location in a second. And then we see I've instantiated the Gemini model, and that is saved in global scope. Now, project and the location. So I can use Google's metadata service to say, hey, what is the project ID and what region is this running in? And to do that, I've written a helper method. So let's go into this helper method code. Now, if you're not running in Google Cloud, for example, locally on my laptop or in Cloud Shell, you need to tell it where your project location and region is, or location. Otherwise, if you are in Google Cloud, you can use the metadata service to request the project ID and the region. Otherwise, running locally, I just send back the hard-coded value. So back in the main app, okay, I have my client library instance, my Gemini model instantiated when the app is spinning up. All right. So now inside the WebSocket handler, so whenever the WebSocket is connected, yes, you have to love it when the comments are 8 times longer than the line of code. Okay, to keep this demo short, I am not persisting chat history here. So this is not going to be saved beyond the current WebSocket session. So if Cloud Run were to tear down this instance, you would lose chat history. In the collab, I go step by step how you can use Firestore to create a Firestore-backed Express session to persist the current chat history. Now, in real world, real life, you're going to have some sort of user ID, user authentication that you can use to save the history. But again, the take-home message is Cloud Run is stateless. Keep this in mind when you are designing your code. Now, with all that said, we're going to start a chat session with Gemini. And then here, the change is instead of responding hard-coded, we will send message to Gemini, get the response back from Gemini, and send that back. And now, and then, yes, let me show how you use ADC. So I need to authenticate locally. So right here, I'm authenticated with my demo account, the Rolf Araz. It's my username spelled backwards. And then my identity already has the Vertex AI user role. So I'm going to authenticate using that. And so this is going to start an OAuth flow that saves an authentication token. And here you see these credentials will be used by any library that requests ADC, hence the Vertex AI client library. And so now, npm run start. And all right, Gemini, C#, programming language or musical note? And Gemini says, programming language. But what if I'm in guitar class? Low E of the 9th fret. I'm working on it. Okay, in the context of guitar class, C# we refer to a musical note. Oh, second fret of the 6th string, or low E, okay. All right, so now we've tested it, we know it works locally. Now let's deploy. So normally I always use gcloud run deploy. I use that command because any required fields is going to prompt me, but I want to demonstrate principle of least privilege, so I have a service account here that also has a Vertex AI user role. So let's deploy this to Cloud Run. And some of the required fields are where is your source in current directory, and we're going to go with demo name. Okay, first in the call is, it says building using build packs. I do not have a Docker file over here, as you can tell. So it is producing that container, a production-ready container for me. And also, if we go to the service account script, again, I go through this in the demo. I show you how you can apply that principle of least privilege by assigning the Vertex AI user role to the service account that will be used as the Cloud Run identity. Now, while that deploys, let's go over to Cloud Run. So so metrics, let's take a quick peek. So again, out of the box performance monitoring. I did a couple of quick tests this morning, as you can see here. Networking, so ingress and egress controls. If you are using the serverless VPC access connector, please check out direct VPC egress, which is now GA. One of the default flags is for authentication. I previously deployed this, which I allowed allow unauthenticated invocations because this is a public, this is a website. Integrations. So integrations makes it easier to create resources for Cloud Run services instead of having to go step by step through all the docs. For example, for Cloud SQL, an integration for Cloud SQL will check the service accounts for permissions. It will prompt you if you need to enable any APIs. And it will also spin up any resources that you might need. There's also a Vertex AI integration. And here, I've already enabled any APIs and granted the Vertex AI user role. All right, and at this point, it should be live. And yes, I see the URL here. So we'll click that. And see, Gemini, once again, see programming language or musical note. And programming language. Yeah, I concur. Pretty much 24/7 minus that 1 to 2 hours that I'm practicing guitar. So that concludes demo 1. So in the second demo, you will see how you can give Gemini access to real-time data by using a new feature called function calling. Since LLMs lack access to information after their training data, they can seem frozen in time, leading to stale or incorrect responses. Function calling helps address these scenarios by letting developers pass a description of a function to a language model. To be clear, you as a developer make the function call, not Gemini. And we're going to go over this now with a step-by-step illustration. So first, the prompt request for the current weather at a given location, and the prompt plus the function definition for get weather is sent to Gemini. Then Gemini asks the app, Gemini asks that the app call get weather in Seattle on its behalf. The app makes the call to get weather in Seattle, and the app gets back from the API 40 degrees Fahrenheit and rainy. The app sends the results of that function call to Gemini, And Gemini answers the customer question 40 degrees Fahrenheit and rainy. So if you're in the, some use cases for function calling. You're in a multi-turn chat, and you might want to tell the user, hey, I'm working on that request on your behalf. Or you need real-time info like weather or currency conversion. Or perhaps you want to make a SQL query based on the user's question. So let's see demo 2 now in action. All right, so first let's pick up where we pretty much left off with demo 1. So we asked Gemini, what's the current weather in Seattle? And Gemini says, I don't know. I don't have access to real-time information. Again, that frozen in time. So I have a Cloud Run service, a weather service that I previously deployed. I really should have named it hard-coded weather, because in Seattle, it can only be 40 degrees Fahrenheit, rainy and overcast. Ask me how I feel about Seattle. Or New Orleans, or New Orleans. I have a Rolodex, I can keep going. New Orleans, okay, now I'm done. Yeah, it's 99 degrees Fahrenheit, hot and humid. Hence the hard-coded weather. And I return the hard-coded units Fahrenheit. So let's curl this endpoint. Like as I said, I previously deployed this. And it comes back, the JSON comes back as 4 degrees Fahrenheit, and so on. Right. So let's switch back to this chat app, pretty much where demo 1 starts. Okay, so the one change, we're going to make a couple of changes. So the first, we have to let Gemini know, hey, there's this API that I have running in the Cloud Run service that's available for you to call. And its name is getWeather, and we give it a description, get weather for a given location. And then we have parameters about the required fields. And then in the WebSocket event handler, we're going to let Gemini know about this function when we start the chat. Only in JavaScript can you just comment out the middle of a line of code. So now, when we start our chat, Gemini knows about it. Now, if we scroll down, this is where things deviate a little bit from demo 1. Now we're going to check to see if Gemini wants to call the function. If it does not want to call a function, this is basically the same as demo 1. But if Gemini does want to call a function because that field contains content, it's not undefined. It is defined. There we go. It is defined. Then we can log it here, and then we, as the app dev, make the call on Gemini's behalf. So here I call my hard-coded weather service with the name that Gemini specified and the location that Gemini is requesting. I get that data back. Then I have to construct an object for Gemini to know, hey, we called this method, and this is what the response was. And then we send message, but now we send it the results of that function call, because Gemini is actually expecting that. And then we send the answer back to Gemini. So let's see. So this time, Gemini is aware of the function. So hard refresh, what is the current weather in Seattle? And Gemini says, the weather in Seattle is rainy, overcast, with a temperature of 40 degrees Fahrenheit. And that concludes demo 2. I see we have some JavaScript fans in the audience. All right, for our third and final demo, this is actually not a Gemini demo. Instead, you will see how you can use the specialized Vertex AI APIs to perform specific tasks. And you'll see Cloud Run jobs. A job runs a container to completion, and then it's torn down. You'll see how a Cloud Run job can process a video to produce visual captionings for each scene. So in other words, this is going to be text-based descriptions for each scene in the video without any audio. So I'm just processing visuals of the scene. There is no audio in this video, in this demo. So first, the video is sent to the Video Intelligence API to detect each scene change and generate a timestamp for the scene change, as shown here in this array of timestamps. Then FFmpeg is used to produce a screenshot for each timestamp, as shown here in these file names. And lastly, the screenshots are then sent to the image text model to produce a visual description of each scene, as shown here in the final output. So we're going to detect the scenes, get those timestamps, and then get a description of the image at each one of those scenes. So let's see demo 3. So first thing to notice is that there is no web server this time, no Express server. It's a job. A job runs a container to completion, and then it's torn down. So we're just going to run this code. I could also, with Cloud Run jobs, I could have this execute on a schedule using Cloud Scheduler, or I could use workflows. But for demo purposes, I'm going to manually execute this with hard-coded values of the video that I have in a cloud storage bucket, as shown here. So the first step will be to download the file locally. And then we're going to use the Video Intelligence API to detect the scene changes and return an array of timestamps. So let's go into that helper method. So here I am using the Video Intelligence client library, and since it is a client library, authentication is handled for me. And then the more interesting parts of this is the feature in the request. I'm using, it says shot change detection. I am using the terms shot and scenes interchangeably. But if you use this, this is why it is called shot change detection. But you can think scene change detection for this. Now here's the call to the client library with the video and also what to look for, which is the scene changes, and then we await the promise. Then we have our scene or shot changes. Then I do some lightweight data processing on that array that comes back, and so on and so forth. And then at the bottom, I return that array back. So let's go back into the main code. Okay, so now I have my timestamps, like 1, 7, 8. Okay, so part 2, we're going to use FFmpeg to grab screenshots at each location. And I need to use a Docker file this time to install it. So you can see here that if you have a Docker file, Cloud Run will use that Docker file. If you do not, then it will use build packs. All right, so now let's go into the helper method on how to use FFmpeg. And the interesting part here is in this method, we're basically going to say for each timestamp in the array of timestamps, produce a image using this file format and save it locally. Now we have our images for each of the scenes. Now, you've been watching me use the client libraries this entire time, but let's say that your favorite programming language does not have a client library. What can you do? So for this part of the demo, I'm going to show you how you can use the Vertex AI directly via REST APIs. So the first thing you need to do is have an access token. And for this, I'm still going to use a client library to get the access token, but there are REST API endpoints that you can use for getting an access token. So I have my access token, and now for getting a visual description or image captioning for each of those screenshots, I'm going to use the REST API. Now, this part is just JavaScript speak for process all this code, and when everything is done, return this JSON object. And all this code is where for each of the images, we're going to call out to the vision description or vision captioning. So let's take a peek here. Okay. So again, this code is going to show you how to call Vertex AI APIs directly. So I have, in my post request, in my headers, I have my bearer token as the authorization header. And then here's the endpoint for the image text model. And then it returns back the text-based description of what is happening in that screenshot. So back in the main code, we do all that runs, and then when everything is done, JavaScript will return a JSON object for each of the timestamps, a description. And then I log that, and that is my Cloud Run job. So I've already deployed this. So we're just going to run the job manually. And similar to gcloud run deploy, it's gcloud run jobs, and then whatever specific commands for a job. And here we're going to say execute video describer job. So while that is running, let's go and take a peek at a job. So actually, it came back and said that your job is currently running. It's currently being executed there. So let's go back to Cloud Run. I'm going to show you where you can find jobs. So jobs that are here, and we see that the video describer job is currently running. And I want to just show a couple of things. So notice that it's very similar to a Cloud Run service in terms of its feature set. So this is something new, volume mounts. We announced this about 2 months ago. So volume mounts, you can now, for either a job or a Cloud Run service, where you can access content in a network file system or NFS or a cloud storage bucket. And this is where you're going to, read operations are going to use the network. So this is a volume mount, to be clear there. All right. And then also, let's see that video. So this is the video that I have hard-coded in the cloud storage bucket in my app. Let's open this. Again, there is no audio. Okay. In this quick 8-second video. So first, there's a white background and the text, what is Google Cloud Vision API, question mark, appears on the screen. And then a woman in a red shirt begins talking as a speaker. And then in the upper left-hand corner, it says, what is Cloud Vision API? So that is the video that we just processed. And let's go to back to our job. Actually, let's go. So now I'm using VS Code because when I executed my job from VS Code, it tells you where you can go check the status. So going to that link, opening that up, I'm directly there to that job, to that specific job. And if we go to logs, and if we scroll up, we see timestamp 1, what is Google Cloud Vision API, question mark, is written on a white background. Timestamp 3, timestamp 8, so on and so forth. So again, that is how you can use Cloud Run jobs to run a container to completion. And with that, that's the third demo. So yeah, let's recap. Okay, so today you saw an overview of how you can let Cloud Run handle your auto-scaling needs while you get to focus on your code. In Demo 1, you saw how you can incorporate Gemini into a chatbot app on Cloud Run, and you saw how you can use the Google client libraries to handle authentication to Google APIs for you. In Demo 2, you saw how you can use function calling so that your large language model isn't frozen in time. And in Demo 3, you saw how you can use the specialized Vertex AI APIs for a specific task and how you can use Cloud Run jobs to run a container to completion. I really enjoy what I do, and I hope I've inspired you to try Cloud Run for your next business idea. And for questions, I will take questions out on the porch and also in office hours today. Thank you.